Hello guys, this is my first video tutorial on NS3. Before we go to this tutorial, I would like to say that you need to install NS3.26 or whichever is the latest version, and you need to build those files. So I'm not going through that tutorial, and if you want to go through that tutorial, I will give those links for installation of NS3 and build of NS3 in the description of this video. You can check out those links. So I would directly jump to the code, a basic code to run NS3.26. That is so here I have installed in my NS3 project folder. So this is the folder that would be created after downloading an installation. And if you go through this folder, this is the NS3.26 scratch, and this is the basic CC file which is written, and this is just like a hello world program in C or C++, and these command lines are mentioning the license of the NS3.26, whichever is the latest, and generally these command lines are maintained to write the author names and etc. And this is the including of header file as same in the C++. The only change is that as this is the NS3, you will just insert the header module of the NS3 core. So this core module.h defines that it's similar to like IO stream in C or C++. It's like similar to that. So this loads all the core properties of NS3, and this line is similar to the using namespace std, like which is used to have input and output functions. Similar to that, NS3 is another variable which is used to have which is used to run this NSLog simulator and all these things. And in Ubuntu, especially C++ is written in int main with this format, and we will return some value as return 0, and here it's not written, but still it runs. And this is just a simulator run and destroy. First we will run this file, then we will go through what this is exactly. Okay, so I'd like to go to the terminal. Unlike C++, this is somewhat different to execute the file. So I would first change my directory to my thing NS3.26. So actually the files are executed depending on WAF build. So /WAF, this is the syntax to run any file. So from the scratch I am loading my scratch simulator. So I'll just press tab, take out that CC, then just run. So it is entering into the directory of the build, and it will start to compile the scratch simulator.cc file, and it is compiling the first .cc. This is the scratch simulator.cc, which right now we are viewing here. This is the one. So now these both files are going to link. Yes, done. So the build is completed. Yes. So here we have written this is just like a print statement in C++. NSLog unconditional is a logging variable. So I would skip this right now because we will talk this in detail in the later tutorials. So it's simply remind that this is like a printf statement or cout statement in C or C++. So the same thing in NS3. So it has been printed as scratch simulator. So this is the basic video. And how does this run actually? So NS3, whenever this core module is loaded, so you need to specify these two things: simulator run and destroy. So when the simulator run function is called, so everything, the code above this run function is executed, and destroy function obviously destroys the whatever the pointer variables, what all the pointers created in it. So it will destroy everything in this. So once we go here, and so I would like to go through this in detailly using another file, which is first.cc. This is a simple network created between two nodes. This is a simple network, point-to-point network created between two nodes, and this first.cc is actually explained inside the tutorial of NS3. So if you download the NS3 software, you can have a clear picture about this first.cc. What is this exactly? So I'm just going through the first.cc. So this is the similar as seen in the previous code. So I'll close this so that any confusion will not be there. These are the command lines as you have seen previously. Yes, and here the hash include core module.h. This was the only header file which we have seen previously, and these are the new header files which you are now seeing. So we'll go through these header files, not now, but we'll just remind that these header files are used for this script. That's it. We'll talk these header files later in brief. This is the same thing, similar to using namespace std for printout and printf statement, similar to that. And this is the main start, and this is the return 0 statement. And before that, as you have seen, this is the simulator run and destroy to run the software and destroy the software, like not the software, to run the simulator and destroy that pointers in the simulator which have been created before. And just if you go through this code, this is the command line cmd.parse. So we'll go through this first. What is this? Command line is just like a function. It's like a class. Actually, it's a class. So I'm defining an object. So parse is a function inside that. What I can do is, if I want to declare any additional variables, so if I want to declare any additional variables from the terminal, say for example, if I have the previous code itself like this, and if I want to give some arguments, like say for example in the previous code, if I have some arguments like a variable int a, so I can define the variable a equal to some value a equal to 1. Yeah, if I need to have this extra arguments, like if I define a variable called int a, and if I need to give this from terminal, so I would define like this, and this internally calls this command line cmd and cmd.parse argc and rv. Argc and rv are nothing but just number of this is the number of arguments, and this is the what are the arguments in that. That's it. So, and this variable, these values which we give to these variables are initialized from the command line terminal. So we'll skip this for right now. This is the time set resolution, time in nanoseconds. This is not required exactly right now, because in the future videos or future tutorials we are not going to use this parameter itself. It is just by default, it is always set to nanoseconds, and we can even set it to seconds also. If we just remove the n here, it will set to seconds. So this we cannot means we no need to actually configure this variable. And this log component enable, I will discuss this with you in briefly in the logging tutorial in the coming videos. Yes, this is the main part of the code right now, what we are going to discuss. This is the main part of the code. So here, as I discussed, I'm going to just discuss a simple code. Like I will open a new file and node container nodes. So my basic idea is to create a node, that is, say for example I have a node A and I have node B here. So actually I need to connect these two nodes using some link, any link, whichever link we call it as. So we'll discuss how this network, a small network between A and B, is created using this code. So there is a class called node container which actually creates the nodes. So when you execute this command, like when you write this command, it means that, so this is just giving an object to the class and object dot calling the function and passing some parameter as an argument. So nodes dot create of 2. What this exactly means is, in the stack of NS3, it creates two nodes A and B. That's it. It creates only the two nodes A and B. So going back, and now I need to have a link between A and B. So for now I am assuming it as a point-to-point link. So there is another class called point-to-point helper, which actually creates a point-to-point link. Okay, so don't assume that this point-to-point helper actually creates the link between the nodes. No, it just creates this link, that's it, up to this link, but still it is not connected between the nodes. Only the link is created and the link should be connected between the nodes. So this point-to-point helper just it creates the nodes. So similar to this node container, as I'm giving the object as nodes, here also I'm giving the object as point-to-point, and these are the functions: set device attribute and set channel attribute. For now, just have it as it's an attribute called data rate. I'm setting it as 5 Mbps, and the delay. This data rate is actually the data rate of the P2P link here, and the delay of this P2P link I'm defining it as 2 milliseconds. So here it's better to write here. So this is my 5 Mbps link, and this is my 2 milliseconds of delay. So 2 milliseconds of delay, and it's better to have a small gap between the nodes, so that yes. So now only this part is configured. So a point-to-point link is created with a 5 Mbps of data rate and 2 milliseconds of delay, but still the nodes are not connected. So to connect these nodes, what I'm doing is I'm using another class called netDeviceContainer, and I'm defining an object called devices. What I'm doing is, in the devices, this is a basic syntax to have a link between two nodes. Say for example, point-to-point. If I have a point-to-point, this is the basic syntax to connect two nodes using this. So what actually is happening is, here I am defining point-to-point object for this point-to-point helper class. So the same point-to-point helper class is having the function called install, and this install actually takes the argument or a pointer. It is taking the argument as an object. So this is the nodes. Nodes is the object I have defined for node container. So this install function is actually taking the object as an argument, and it is passing to the point-to-point helper class, and the whole thing is actually it is actually dumped into these devices. So devices, it's an object. So now so in the background, actually what happens is, in the background when I am running the simulator, so when the devices, this command executes, so actually now the link actually will be created. So I can say this as yes. So when I execute this devices equal to point-to-point dot install of nodes, now a point-to-point link between these two nodes is been created. And now I need to have what do you call this, an IP address between these two nodes to communicate. So for this, what I'm using is, I'm using an internet stack helper class to install the nodes on the stack. This is, don't confuse between this stack and the original stack of NS3. So this stack is just an object that is defined to the internet stack helper, but the original stack of NS3 is defined in the underlayers of library files. So what I'm doing is, I'm just installing these nodes onto the internet stack helper, and I'm using some class called IPv4 address helper. I'm setting the base 10.1.1.0, and this is the by default mask. Sorry, this is the by default gateway. So this 10.1.1.0 will be set as a domain to this network. say if I can say 1.1.0 will be set as a domain to this both to the whole network. But what are the IP addresses that have been attached to the each node? That is, when I define an IP address, say like this 10.1.1.0, whichever is the first node, say for example if I consider the A node as the first node, then the A node actually has an IP address 10.1.1.1, and the next node immediately, and the immediate next node has 10.1.1.2. So these are the two IP addresses that are assigned to the nodes. And now what I'm doing is I'm actually like similar to the point-to-point link. What I've done is I've created a point-to-point link, and I've installed point-to-point link between these two nodes. Similar to that, I am defining two interfaces on the same domain. This is the domain, and in the same domain I am actually having two IP addresses. So I need to interface these two IP addresses. To interface this, I am using the IP for interface container as similar to object. What I am doing is similar to the point-to-point dot install of nodes. Device is equal to point-to-point dot install of nodes. I am actually similar to that. I am interfacing these two nodes. Like interface is equal to address dot assign of devices. So the devices actually will be interfaced using these IP addresses. So if you go back now, okay, we'll go here. Now I have a point-to-point link between these two nodes with a 5 Mbps data rate and 2 milliseconds of delay, and A and B are installed on the internet stack with a domain of 10.1.1.0, and IP addresses are as follows for A and B respectively. Now I need to run an application from either A to B or B to A, so that I can say that a communication, at least the communication is being happened between A and B. So communication is present between A and B. So to run an application or to install an application, generally what we do is we will install the application on the node. So we'll install generally on the node, we will install the application. So if you see here, this is a basic UDP echo server helper. It's a class, and to this class I am giving the object and passing the port number as an argument 9. So UDP echo server helper and echo server of 9, which means I am defining the port number as 9. And what I will do is I will install an application using this class called application container, and I am naming it as server. So I actually have a server and a client. So name it as a server, or it's a client, or a server as a client, either case. So what I'm doing is I'm installing as server apps echo server dot install of nodes dot get of 1, which defines that here actually nodes dot get of 1. This is the new point. So get is a function from node container, because I am calling with the nodes object. So nodes dot get of 1 is actually calling the second node. So if I write nodes dot get of 0 like this, that means I am calling the first node. If I write like this, that means I am calling the second node. Here I will assume as this one as first node and this one as second node. That means in the code A will be nodes dot get of 0, B will be nodes dot get of 1. So what I am doing is nodes dot get of 1 actually I am installing on the server apps. It's just an object, but to ensure that it's a server, I am installing on the server apps. So I need to have a application start time and application stop time. When should I start the application? When should I stop the application? Either it can be server side or client side. So both sides. So on the server side and the client side, as I am installing the application on both sides, I need to have the start and stop timings for the application. So as I have server application here, I need to have one more called client application. One is server is to transfer the data packets, and echo it's a client to receive the data packets. So this application actually receives the data packets. So as you have seen here, application, container, server, apps, something. So the same is defined here for client apps also. So what I'm doing is I'm assuming the node B as a server and node A as a client. So what happens here, there is somewhat extra code to define. So what this exactly happens? As I have taken UDP equals server helper, similarly there is another class called UDP equal client helper. So in this client helper, what I'm doing is, for the client, if say for this actually I mentioned it as server A and B as client, right? So B, I'm so sorry. Actually I mentioned nodes.getOf1, that is B as server and A as client. So B, here we will write it, so there will be no confusion. So this is defined as client and this is defined as server. So as I mentioned here, the UDP echo server of, as I've given the port number, similarly I've given the same port number for client also, but with an extra argument called interfaces.getAddress_of1. Interfaces is an object given to IPv4 interface container, and in that we have the devices which are assigned with a particular IP address. Now it should be very easy to understand this for you. Interfaces.getAddress_of1, what I'm doing is, here getAddress_of1 is nothing but interfaces, I'm calling this class dot get address. So I'm actually calling this particular address, this is a domain, but I'm calling an address from this domain, and the address of which one is the 1. That means it calls the address of the device 1. Device 1 is nothing but B, because device 0 is A, device 1 is B, similar to node 0 and node 1. So node 0 is A and node 1 is B, so device 0 will be A and device 1 will be B. So I'm getting the address of B, and I'm saying that the same port number I'm defining here. So these are some of the attributes to the client I will set. We will go through this briefly in the next tutorials, in the coming tutorials. This is the max packets, only one packet I'm going to send. So the interval between each packet is 1 second. So as I'm defining only one packet, there is no sense in making this interval. So it has actually come by default with the NS3 software, so I am not going to change this. And packet size, so I'm going to transfer only one packet, and my packet size is 1024 bytes. This value is by default in bytes, so 1024 bytes. What I'm doing is I'm starting the server at 1 second and stopping the server at 10 seconds, and here I'm starting the client at 2 seconds and stopping the client at 10 seconds. Here actually what happens is, from the client the packets transfer to the server. So from the client the packets actually transfer to the server. So the direction of transferring would be in this way. So from the client to the server, actually the packets are going to transfer. Now we have seen this whole code, and we also have the whole network scenario. So we'll just run and make sure that the data transfer, like I will say, what is the data transfer? It's nothing but one packet, that is 1024 bytes, are actually going from 10.1.1.1 to 10.1.1.2. But wait, in the code, if you clearly observe, these are echo. That means whatever the client sends to the server sends the same to the client. It's just like a testing thing, like you do a internet speed test, or some random amount of MB is transferred from your side and the upload speed is calculated, and some random amount of data is downloaded from the server side and download speed is calculated. Similar to that, so 1024 bytes is sent initially from the client to the server, and as it is an echo application, again from the server to client I will get 1024 bytes back. So we will check this out by running it. So the file name is actually first.cc. So I will give the file name as, I'll just clear the terminal and I'll place it in the middle. So /waf, just I will run scratch/first. That's it. There is no need of .cc extension. It will throw an error if you give the .cc extension. Just will run this file. So it's entering into the directory. Yes, actually it was compiled previously, so it will not compile it once again. If we go here, yes, if we go here, it was compiled previously when I was running the scratch simulator file, so it will not run once again. Yes, as I've told you, we will go through the application. From the client, which is starting at 2 seconds, the number of bytes is 1024. 1024 bytes will be sent to 10.1.1.2. This is the B node. So as I said, as the application is starting at 2 seconds, so at time 2 seconds, client sent 1024 bytes to 10.1.1.2, right, through port 9. And at time, this particular time, this is calculated by the NS3 time class. So this we cannot actually, if we go through the time class, we can actually have these timings. Even we can calculate what is the timing for the next event. So at this time, server is actually receiving the 1024 bytes which is sent by the client. I'm sorry, a small mistake should be done. This is actually the 2 and this is actually the 1, because if we see here, client sent, sorry, I'm confused actually. Yes, so this is the server. So server, this is the server. So server received 1024 bytes from 1.1, so 1.1 through some random port. As it is an echo application, at the same time again the server is sending 1024 bytes to 1.1 back. I'll just click this here. Yes, so 1024 bytes. So the server is actually sending back 1024 bytes to the client. So this I can write it as, this is the first step where client sends to server, and the second step would be client would be actually receiving the packets from the server. So this is the second step, because this is done because we have mentioned it as application, that is echo application. So if you see here, and at this particular time, client is again receiving 1024 bytes from 10.1.1.2. So this is the basic explanation of a simple network. So this is my this is the tutorial on explaining the simple point-to-point network and how the data actually transfers between one thing to another thing. Thank you guys.